Yeah, good morning, students.
Good morning.
His voice is audible?
Yes, sir.
Yes, sir.
Okay. Okay. What is the last topic?
Delta E approach.
Delta epsilon, not E. Correct?
Yes.
Yeah, okay. Next one. Yeah, serious problem. Find the limit of, or the question is limit x comma y tends to 0 comma 0 xy upon x square plus y square, x square plus y square. Okay. Equal to, what is the answer? Solution. There are two ways to solve this problem. One is delta epsilon approach. Another one is, I told you one note. What is that? In two-dimensional plane, when xy is approaching x0, y0, this is xy, and this is the point x0, y0. This may be approach along a straight line, along any path, okay, like this. The limit must be unique. Whatever xy tends to x0, y0 along any path, the limit value must be unique. That is the point. And what is x0, y0 here? 0 comma 0. First, let me write here. F of x comma y is xy upon x square plus y square. And what is the point? x0, y0 is origin. x0, y0 is origin. Now, let me define that along any path. If, and remember, whatever the path you consider, that must be passing through what point? Origin. It must passing through x0, y0, means origin. Let xy tends to 0 comma 0 along a path. Generally, what is along a path? I can take y equal to x. It is a straight line passing through origin, or y equal to some 2x, y equal to 3x, or y equal to x by 2, y equal to x by 3, like that. Whatever that is, it is a straight line, family of straight lines passing through origin. So in general, one can take y equal to mx along the path where m is the parameter. Y equal to along a path y equal to mx, or one can take y straight line. I will take parabola y equal to mx square. Choice is yours. But whatever the curve we are choosing, that must be passing through origin. That is the condition, the path condition. Then if I consider y equal to mx simply, then what is dy equal to? No need of dy, right? No need of dy. Then what is this? Becomes limit x comma y tends to 0 comma 0. What is this? Xy by x square plus y square is equal to limit, and y equal to mx na. Therefore, as xy tends to 0 comma 0, what is xy? What is the meaning of y equal to mx? We are replacing y in terms of x. Then in terms of x means completely we are getting in terms of x terms the function. So clearly this is x into mx, you write, or mx square. Choice is yours. Mx or mx square by, what is this? X square plus m square x square. Now what is this function? This is completely in terms of x. Therefore, as xy tends to 0, 0, x tends to 0. I need only x tends to 0. Therefore, this is limit x tends to 0. What is this? Becomes mx square over x square is common, 1 plus m square. Now x square gets cancelled. What is this value? Limit x tends to 0, m over 1 plus m square. M over 1 plus m square. You see, this function, this m by 1 plus m square, clearly it does not depends on x, right? Even though limit x tends to 0, which is independent of x, which is independent of x, and the limit value depends on m. M is unique. Y equal to mx. One can take m equal to 1, y equal to x, or y equal to x by 2, like that. Depends on m, which is not unique. M value is not unique. Since m value is not unique, the limit value may be anything. Therefore, the limit is not unique. Therefore, limit xy tends to 0, 0. Limit xy tends to 0, 0. What is the question? Xy by x square plus y square does not exist. This is one model problem to find the limit of a function of two variables. Let me see one more problem. What is that? Find limit xy tends to 0, 0. Xy by, I will solve this problem in two ways. One is delta epsilon approach. Another one is our independent of path of integration solution. First, let me write the independent of path integration. What is f of x comma y? Let fxy equal to xy by under root of x square plus y square, right? And what is the point x0, y0? This is the origin 0, 0. Now let xy approaches 0, 0. Along a path passing through origin. That is, choice is yours. Let me consider y equal to mx again, or you can take y equal to mx square also, right? Y equal to mx. Then as xy tends to 0, 0, this implies x tends to 0. Because why I am writing x tends to 0? Y is in terms of x we are defining. Therefore, limit xy tends to 0, 0. Xy over under root x square plus y square is equal to. Now this is completely in terms of x by substituting y equal to mx by this is x square plus m square x square. This is equal to limit x tends to 0. This is x square, m x square, and here x square is common. Outside x you will get 1 plus m square. So 1x gets cancelled, and since this is 1x is there here, what is the value? 0. That means the value is 0. It does not depend on this one. Therefore, limit exists. And is what value? Limit xy tends to 0, 0 of xy upon x square plus y square is 0. Or let me solve this problem using delta epsilon approach. Okay. Now coming to delta epsilon approach, just for your idea, what is delta epsilon approach? Just I'm giving the definition once again. F of x comma y minus L less than epsilon whenever, what is the condition? Whenever, what is that? X square plus y square under root less than delta. This is the origin. Okay. Origin is there. Point is what? Otherwise, what is the point? 0, 0. That is why I have taken x minus 0 whole square plus y minus 0 whole square, right? X minus 0 whole square, y minus 0 whole square is less than delta. Okay. Or another condition is what? X minus 0. A mod x minus 0 less than delta and mod y minus 0 less than delta. Okay. All these are choices. Okay. Now, coming to what is here, clearly here, what is L value is given in the question? 0. L value is given. Show that. Actually, question is show that maybe. This is show that. In delta epsilon approach, definitely this limit value must be given. Otherwise, you cannot apply delta epsilon approach. Remember this point. Okay. Here, L equal to 0. Therefore, mod f of xy minus L, what is this becomes? Xy by under root x square plus y square minus 0. Minus 0. What is this value? This is the modulus of this value. Xy by x square plus y square. Xy by x square plus y square. And how to write this one? In terms of I need, what is this? This must be less than epsilon. This must be less than epsilon. So I can write this value less than or equal to, less than or equal to. The hint is, let me write here. Let me express in the numerator in terms of denominator values. That means what? What is x plus y whole square? X plus y whole square value. You write x square plus y square, x square plus y square plus 2xy plus 2xy. So obviously the thing is how to write this. Xy is there. So if I consider xy, this is x square plus y square by 2. Definitely this xy must be less than or equal to, xy must be less than or equal to 1 by 2 of x square plus y square. Just this is one logic to get less than symbol. So this is less than or equal to, how can I write? Mod 1 by 2. Yeah, 1 by 2. And what is xy? This is x square plus y square by under root of x square plus y square. Under root of x square plus y square. Now this is equal to what? 1 by 2 under root of x square plus y square. So this is the logic. Xy is definitely less than or equal to x square plus y square by 2. Now I'm getting this value. This value must be what? Less than epsilon. Therefore, mod, how to write? Yeah, let me write. Xy minus L is less than or equal to what? This is, these two are equal. Coming to comparing this, less than or equal to 1 by 2 under root of x square plus y square. And what is this? Must be less than epsilon. This must be less than epsilon. And for what? Definitely this xy is not equal to 0 comma 0. Not equal to 0 comma 0. And next one, what is this? You write, after getting this, I have to get delta value, no? I have to get delta value. Therefore, what is this value? X square plus y square is less than 2 epsilon. I'm getting. This implies mod f of xy minus L less than or equal to root of x square plus y square less than 2 epsilon. Therefore, how to choose? This is delta, right? X square plus y square. This x square plus y square, it is here less than epsilon, delta, about the point 0 comma 0. That is why it is x square plus y square. Therefore, if we choose delta is less than 2 epsilon, then if I choose delta less than this 2 epsilon, then we get our limit. X square plus y square is less than 0, is less than epsilon whenever what? Whenever, what is the point? X square plus y square under root less than epsilon, less than delta. And remember, see why I am considering xy not equal to 0 comma 0. In the function, if I put 0 comma 0, what is this one? 0 by 0 form, indeterminate form. Therefore, xy not equal to 0, 0 means what? This is the point 0, 0. I am excluding this, means this is deleted neighborhood. This is what? Deleted. Whenever deleted neighborhood, I told you 0 less than, delta, root of x square plus y square less than delta. This is for deleted NBD neighborhood. For deleted neighborhood, you must write this x square plus y square greater than 0 and less than delta. This is delta epsilon approach. Once again, I'm telling delta epsilon approach. This is the definition. Actual definition is x minus a whole square plus y minus b whole square less than delta, where limit value is at AB. Now AB x minus x naught, y minus y naught. X naught, y naught is what? 0, 0. That is why this becomes x square plus y square less than delta. I have to prove this. and I know value of L. And remember, delta epsilon approach is applicable only when limit value is given. Show that something. Here L value 0, so I have considered this and I'm getting this. To simplify this, I have to remove this product term xy. So write product xy as xy is definitely less than or equal to x square plus y square, and you put mod. That is better. Mod xy is less than or equal to x square plus y square, x square plus y square by 2. That is why I have replaced this and I am getting this value. Clearly about the point, and this value must be less than epsilon as per the definition. Mod f of xy minus L less than or equal to this value, and this value must be less than epsilon. So this is less than 2 epsilon now after next step. So I have to choose delta what? Delta must be less than 2 epsilon. So if I choose delta less than 2 epsilon, this definition is valid. That means this definition is valid. Hence, this is the definition of the limit approach as per delta epsilon definition. So this is the valid. So limit value is 0. Somewhat delta epsilon approach is somewhat difficult, not difficult, but you have to guess. You have to simplify this expression to get less than epsilon. Okay, only this is the problem. Right? Next one. Let me take definition of continuity. Continuity. You know, generally continuity means what? See, in intermediate, this is x-axis, this is y-axis. This is the point A. This is the point A. What is the definition of a continuous function? Limit f of x as x tends to A is equal to f of A. If this is true, then f of x is said to be continuous at point A. Continuous at point A. Now to evaluate this, what we have to consider? Limit x tends to right limit and left limit x tends to A minus f of x. To evaluation of this limit, both left and right limit must be same and both must be equal to f of x. Both must be equal to f of x. Means what? For example, the shape of the curve is like this. When x is approaching A through left side and x is approaching A through right side, the curve may be, this value must be same at this point. Both left limit and right limit are same. Then curve is said to be, yes, now this is continuous. This is continuous. Left limit, right limit value at A is same. Therefore, there is a continuity of this curve. For example, okay, let me write here itself. This is the point A. Left limit value A minus f of x value. For example, this is 1. And right limit value A plus f of x. This value is 2. I'm taking example only. So the curve shape of the curve, this is 1 means here. The curve may be coming like this and 1 here. And what is the when x approaching A through left side? When x approaching A through right side, what is the value? 2. Means the point is here. The curve like this. That means there is a gap between this left limit and right limit. This is called jumped discontinuity. This is called jumped discontinuity. Jumped discontinuity. The curve is not continuous. Not discontinuity means not continuous. That means left limit value, right limit value, both are different and not equal to f of x. Okay. So continuity means what? This is the continuity definition in single variable. Now coming to two variable definition. A function z equal to f of xy is said to be continuous. At a point, take point x0, y0. At a point x0, y0, if, see the conditions. First thing, the function value must be defined here. The function, this is f of a, must be defined. Therefore, here in place of f of x, f of xy is defined at what point? Is defined at the point x0, y0. This is the first condition. The function must be defined at the first x0, y0. And second condition, limit x comma y tends to x0, y0. F of x comma y exist. The limit value must be exist. Second condition, limit value exists. And what is the third one? Both must be same. That means what? Limit x comma y tends to x naught y naught of f of x y. It must be equal to what? F of x naught y naught. This is the main part. So actually this third condition is enough. But to define third condition, what we required? Yes, the function f must be defined at x naught y naught. And second condition, this limit value exists. And third one, both must be same. Then function is said to be continuous at x naught y naught. Continuous at x naught y naught. Now take one simple example for this. Test the continuity. Test the continuity of the function at 0, 0. At 0, 0. And the function is f of xy equal to 2x power 4 plus 3y power 4 by x square plus y square. This the function value at a non-zero point. And another one 0 when xy point is 0, 0. When xy point is 0, 0. Continuity means I have to check this condition. Okay. And clearly see, I have to check at what point 0, 0. That means x naught, y naught is 0, 0. What is at 0, 0? The function value 0. That means f of x naught, y naught 0. This is over. The first point is, the first condition is over. At 0, 0, what is the function value? 0 is given. And second one, I have to check limit value. Limit of what this? Limit of this function I have to check. Right? So first one, f of xy. F of xy equal to 2x power 4 plus 3y power 4 by x square plus y square. This is xy not equal to 0, 0. And what is the point? What is the value? F of 0, 0 is given as 0. So let me check limit value now. Limit value. Now we have to check. We have to find, right? We have to find limit xy tends to 0, 0 of what? F of xy. Of f of xy. Now let me write limit xy tends to 0, 0 of what? 2x power 4 plus 3y power 4 by x square plus y square. So which method better? Along any path is better. Let xy tends to 0, 0 along a path y equal to mx. Along a path y equal to mx. Then as xy tends to 0, 0, we have x tends to 0. We have x tends to 0. Then limit xy tends to 0, 0. 2x power 4 plus 3y power 4 by x square plus y square is equal to limit what this becomes? X tends to 0. Now substitute y value. What is the y value? Mx. So this by x square plus m square x square. X square plus m square x square. That is equal to, what is the common? X power 4 is common. So 2 plus 3m power 4 by x square is common. 1 plus m square, and limit x tends to 0. So definitely this value is what? 1 x square gets cancelled and remaining part x square is there. Okay. Remaining part x square is there. Therefore limit x tends to 0. X square into 2 plus 3m power 4 by 1 plus m square. This is equal to 0. Since limit xy tends to 0, 0 of what? F of xy is equal to f of 0, 0 equal to 0. The given function is, the given function is continuous. Continuous at origin. Continuous at origin. Okay, this is one model. For discontinuity, yeah, you can consider so many examples. Let me tell you one problem for discontinuity. See, another one. Test the continuity. Test the continuity of the function. Test the continuity of the function at 0, 0. What is the function is given as f of xy is equal to x square minus x under root y by x square plus y. This is xy not equal to 0, 0, and this is equal to 0 at xy equal to 0, 0. Xy equal to 0, 0. Okay. So directly solution. What is f of 0 given? What is f of 0, 0? 0 is given. So I have to find the limit. Now, to find the limit x comma y tends to 0, 0 of what? X square x root y by x square plus y. X square plus y. Take xy tends to 0, 0 along a path. See, I will take again mx. Let me try another one also. Okay, let me try another one also. Y equal to mx. Then limit xy tends to 0, 0 x square minus x root y by x square plus y equal to limit x tends to 0 x square minus x into under root mx over x square plus mx. Done. That is equal to class 1 only. See, if I take what is this, if I substitute, nothing will come, I think, right? Limit x tends to 0. Limit x tends to 0. X square minus root m into x power 3 by 2 you will get by x square plus mx. So if I put this one, you will get what? 0 by 0 form. 0 by 0 form, right? That means I'm not getting any conclusion here. That is why you change this part. You change this part. So, okay, this is one idea. Okay. So take another path. Take another path. Anybody, what is the substitution? Take another path. Y equal to, so that the square root terms, this x terms should be taken common. If I put y equal to something, yes, y equal to
mx square.
Okay, right. If I take mx square, then what is this becomes? I think you got this idea, na? When I take the path, you have to get the limit value. Otherwise, you consider another path. Xy tends to 0, 0. X square minus x root y by x square plus y. So this is obviously x tends to 0. X square x into root mx, correct? By x square plus mx square. Yeah, now you can take x square terms common. Exactly. So this is limit x tends to 0. After taking x square common and getting cancelled, the remaining term is 1 plus m, which depends on what? Which depends on m, which is not unique. Which is not unique. Which is not unique. Therefore, limit does not exist. Therefore, limit does not exist. Therefore, what is limit does not exist means what? Therefore, limit xy tends to 0, 0. F of xy, this is does not exist. Not equal to what? F of 0, 0. Hence, fxy is discontinuous. Fxy is discontinuous at what point? 0, 0. This is one model problem for discontinuity. One can solve the problems by using polar coordinates also. That means to evaluate the integral, to evaluate the limit value, you can put x equal to r cos theta, y equal to r sin theta, then take limit r tends to 0. Okay, always just I am giving hint, but hint to find limit. One can transform the problem to polar coordinates. By taking x equal to r cos theta, y equal to r sin theta, then limit r tends to 0. What is okay? Limit, you write like this. Limit xy tends to some x naught, y naught, whatever the point, f of xy is equal to limit. This becomes r tends to 0. This becomes r tends to, particularly I'm taking 0, 0 only, origin, r tends to 0, f of some r cos theta, r sin theta. Okay, and limit must be independent of theta. Limit must be independent of theta. That means limit r tends to 0, if we get finally tan theta, limit r tends to 0, tan theta you are getting, then what is the value? As theta varies in polar coordinates, I told you what is the how to draw the graph about the angle line, theta equal 0, theta equal pi by 4, pi by 2, like that. So theta varies, tan theta also varies. That means limit value not unique. Okay, so for the existence of the limit, what is the condition? Limit must be independent of theta. And next one, yeah.
Sir, to evaluate that 0 by 0 form, can we use L-Hospital, sir?
Where?
In the first y equal to mx case.
Again, see, x power 3 by 2 is there, no?
Yes, sir.
Right. Okay. If it is not there, you can apply.
Okay, sir.
Okay. 3 by 2 is there. Therefore, if I take the derivative, you will get negative powers, right?
Oh, sir. Oh, sir, if we divide by x squared, then we'll get 1, sir.
Where?
Sir, in that same limit, if we divide it with x squared, then we'll get 1 minus root of m by x by 1 plus m by x. So if we substitute the limit, will come
Now,
1.
then when x tends to 0, m by x means what? M by 0, infinity, no? Denominator part.
Okay, sir.
Okay. You try.
Sir,
But you should not get indeterminate form. Yeah, tell.
x కామన్ తీసుకుంటే క్యాన్సిల్ అవుతుంది
ఎక్కడన్నా
అదే లిమిట్ ఎక్స్టెన్స్ టు 0 లో
ఏది ఇదా x పవర్ 3 by 2
ఎస్ సార్
x కామన్ తీసుకుంటే
m వస్తుంది కదా సార్
ఇక్కడ x స్క్వేర్ లేదా
x ప్లస్ m అవుతుంది కదా సార్ అప్పుడు
అవును
ఎక్స్టెన్స్ టు 0 అంటే డినామినేటర్
కామన్ తీసుకుంటే ఏం మిగులుతుంది చూడు x మైనస్ రూట్ m రూట్ x మిగులుతుంది కరెక్టేనా
ఎస్ సార్
బై x ప్లస్
m
కరెక్టే కదా
ఎక్స్టెండ్ టు 0 అంటే 0 వస్తుంది సార్
0 వస్తుంది రైట్ వెయిట్ 0 ఆన్సర్ కూడా 0 నా కాదు
Sir, 0 by 0 we are getting.
What?
Sir, 0 by 0 only.
If I take x common, right, I will get x. See, the problem is a very good problem. See, y equal to mx, this is one path along straight line, right? Along a straight line. If I consider another path, y equal to mx square, parabola path, y equal to mx square, parabola path, then what is the value? It is independent of, it is depends on m. So along straight line, we are getting 0 value, and along parabola, we are not getting 0 value. Along any path, limit value must be unique. That must be true. Okay. For this problem, it is not true. Hence, limit does not exist. Same logic you can apply for other problems also. For example, what is this problem? Y equal to mx I have taken. You consider y equal to mx square. In this one, you consider this is one path straight line. You consider y equal to mx square. Substitute here. If we will get 0, then along any path, the value is unique. Okay. Right? Better you take, generally it will not happen in most of the problems. For this problem, it is happening. X square, x is common. Yeah, root x is there. 1x gets cancelled. X plus m. If I put x equal to 0, right? It is value 0. Yeah, 0 by m, 0 we are getting here. But if I consider this path, I am getting the limit depends on m. Yeah, it's not in, does not exist. Limit does not exist. Along any path, limit must be unique. Limit does not exist. Okay. And solve the remaining problems also by taking another path. And next one. And instead of doing, say, let me clarify one more. This is, I think this, you can apply this polar coordinates also. That's better. In polar coordinates, no need of anything. Y equal to mx or like that. Let me try one problem in polar coordinates. Where is it? Polar coordinates. Take this. Just one example. F of xy equal to, just I'm trying this. Let's check whether it is from x into x square minus y square by x square plus y square, where xy not equal to 0, 0 and 0 at a 0, 0. Okay, let me check this. Solution. F of 0, 0 is 0. And f of xy is what? 2x into x square minus y square by x square plus y square. Xy not equal to 0, 0. Xy not equal to 0, 0. Put x equal to r cos theta, y equal to r sin theta. Then what is this becomes? F of r cos theta, r sin theta is equal to 2r cos theta. This is r square cos square, and this is r square sin square, right? By x square plus y square is r square, right? So 2r square is common and getting cancelled. So remaining part 2r cos theta. 2r cos theta. What is this? Cos square theta minus sin square theta. Cos square theta minus sin square theta. So if I apply limit xy tends to 0, 0 of f of xy is nothing but limit r tends to 0 of f of function of r theta. Just I am writing this r cos theta, r sin theta means it is in terms of r and theta. This is limit r tends to 0. Limit r tends to 0 to r cos theta, and I can write cos 2 theta. Since r is there, what is this value? 0. What is this value? 0. Therefore, limit value 0. Therefore, or since limit xy tends to 0, 0 of f of xy is equal to f of 0, 0, f is continuous. F is continuous at 0, 0. F is continuous at 0, 0. This is one problem based on polar coordinates. Okay, by changing to polar coordinates. There is no question of any other path. Directly r tends to 0. For example, if this r is not there, for example, then what is this limit depends on what? Theta. Where theta is what? line. It is a angle line. Theta equal to 0, theta equal to pi by 3, like that. When theta varies, this limit value also varies. Okay, so it depends on theta, then limit does not exist. Next one, yeah, partial derivatives. Next topic, partial derivatives. This partial derivative saying if y is a function of single variable, y is a function of single variable x, that is y equal to f of x, then rate of change in y with respect to rate of change in x is called derivative. In particular, this is called ordinary derivative. I will tell you what is difference between ordinary and partial. Ordinary derivative denoted by dy by dx. Okay. Now there are two derivatives, or generally derivative term is common. In this derivative there are two types. One is ordinary derivative, another one is partial derivative. If y is a function of single variable, then the derivative of y with respect to x is called ordinary derivative. If there is a function z which is a function of two variables x and y, then there are two derivatives exist. If not only two variables, if z is a function of more than one variable, then a rate of change in z with respect to rate of change in x. Listen, rate of change in z with respect to rate of change in x by treating y as a constant is called partial derivative of z with respect to x. Dou z by dou x means this notation is changed. What is d stands for ordinary derivative. And dou stands for partial derivative. What is dou z by dou z x means what? If z is a function of two variables, dou z by dou x stands for rate of change in z with respect to rate of change in x by taking y as constant. This is dou z by dou x. Same logic. Dou z by dou y means what? Rate of change in z with respect to rate of change in y by taking x as constant. For example, if z equal to some 2x square y, then 2x square y cube, for example, then what is dou z by dou x? Derivative with respect to x, 4x, by take y cube common, y cube constant. Similarly, dou z by dou y, if I consider, then this is 2x square, this is 3y square. If z is, for example, 2x square plus y cube, y square or y cube, dou z by dou x means what here? Just 4x. Y cube is constant now, so it's taken as constant when I take the differentiation with respect to x. So this is 4x only. Now dou z by dou y becomes what? 3y square. Like that. This is a brief concept about partial derivatives. And if z is a function of several variables, say z equal to, you consider f of x1, x2 and so on xn, then how many partial derivatives exist? Then dou z by dou x1, dou z by dou x2, and so on, dou z by dou xn. These are first order partial derivatives, all of you. First order partial derivatives. First order partial derivatives. Right? Similarly, dou square z by dou x1 square, dou square z by dou x2 square, and so on. These are called second order partial derivatives. Second order partial derivatives. Okay. Similarly, here there is one change. Z derivative with respect to x1, x2. This is also second order partial derivative. Like this, there are so many derivatives. Here, first I have to calculate dou z by dou x2. What is this? Dou square z by dou x1, x2 stands for what? First, dou z by dou x2 you calculate. For this, dou by dou x1. Dou by dou x1. And in most of the cases, here you write like this. Dou square z by dou x dou y is equal to dou square z by dou y dou x only when z equal to f of xy, now the function z equal to f of xy is continuous function. Z equal to f of xy is continuous function, and second order partial derivatives. Second order partial derivatives are continuous. Function continuous, and those derivatives also continuous. This is the condition. When these are continuous only, these two are equal, otherwise not equal. Otherwise not equal. Okay, I will stop here. Tomorrow class 12 o'clock, no?